Now that you have mapped capabilities, value streams, and operating model expectations in phase B, you are ready to translate that business clarity into information systems architecture that delivery teams can execute and leaders can govern. Phase C is where many transformations either become sustainable or become expensive chaos. If you treat data and applications as isolated technical assets, you will increase duplication, weaken accountability, and create inconsistent experiences. If you treat data and applications as enterprise instruments for delivering value streams and capabilities, you will create coherence, reuse, and predictable change. In this lecture, you will learn how to lead phase C in a practical, outcome-driven way that actually works. Building on that purpose, you should remember that phase C includes both data architecture and application architecture because they are inseparable in the real world. Data architecture clarifies what data matters, who owns it, how it is governed, and how it flows safely across the enterprise. Application architecture clarifies which systems deliver which capabilities, how responsibilities are split, and how the application landscape will evolve over time. When you separate these conversations, you create application decisions that break data quality and data decisions that cannot be implemented. When you keep them together, you can build systems that share a consistent truth and deliver value streams with fewer handoffs and less rework. With both data and applications in scope, your leadership goal becomes clear. You want one enterprise truth for critical data, clear ownership for the systems and data that support capabilities, and a sustainable plan to evolve the landscape without endless rework. Leaders want confidence that customer data, financial data, identity data, and asset data are consistent and trusted. Delivery teams want clarity on where to build, where to reuse, and what interfaces and patterns are acceptable. Operations teams want predictability and reduced fragility. Phase C helps you set these expectations and convert them into decision-ready architecture direction. Now that you know the goal, you need to avoid common failure patterns, starting with data architecture. Data architecture fails when it becomes a theoretical exercise, filled with definitions that do not change decisions. It also fails when data ownership is unclear, because without ownership, data quality becomes everybody's problem and nobody's responsibility. Another failure is treating data governance as an afterthought, which leads to inconsistent definitions, uncontrolled sharing, and high-risk access. In phase C, your job is to keep data architecture practical by focusing on the data that drives the highest value capabilities and value streams, and by assigning ownership and governance that can actually be enforced. With data failures understood, you can use data domains to make data architecture manageable. A data domain is a logical grouping of enterprise data that aligns to business concepts such as customer, product, workforce, finance, assets, or identity. Data domains help you avoid the trap of modeling everything at once. They also provide a clear basis for ownership and governance. When you define data domains, you can clarify which domain is most critical to the value streams you prioritized in phase B, and you can focus architecture effort where it will deliver the most outcome impact. This makes data architecture a strategic planning tool, not a modeling hobby. Now that domains are defined, you need to establish authoritative sources so the enterprise stops arguing about what is true. Many organizations suffer because multiple systems claim to be the source for the same data, which creates inconsistency and operational friction. You clarify which system is authoritative for specific data entities, such as customer identity, service location, billing account, or asset inventory. You also clarify what authoritative means in practice. It means the enterprise trusts it, governance protects it, and changes are controlled and traceable. This is a leadership decision, not a technical preference, because it shapes how teams build, integrate, and report across the enterprise. With authoritative sources clear, you need ownership because ownership is how quality is sustained. You define who owns each data domain and who is responsible for data quality, data definitions, access rules, and lifecycle management. Ownership is not about blame. It is about accountability and continuous improvement. When ownership is clear, you can measure quality, manage risk, and drive investment where data is weak. When ownership is unclear, data quality becomes a hidden cost that shows up as manual reconciliation, customer complaints, and audit pain. In phase C, data ownership is one of your most important governance outcomes. Now that ownership exists, you need a clear approach for data sharing and access because enterprises require data flow to deliver outcomes. The challenge is enabling access for value streams while controlling privacy, security, and compliance risk. You define principles for who can access what data, under what conditions, and how access is monitored. You also define expectations for data minimization and purpose-based use, so teams do not over-collect or overshare. In leadership terms, you are balancing value creation with risk control. A strong phase C approach makes data accessible in controlled ways, which improves delivery speed without increasing risk exposure. With data direction established, you now focus on application architecture, where many organizations accumulate cost and complexity. Application architecture fails when applications overlap in responsibility, when teams build duplicate solutions for the same capability, and when boundaries are unclear. It also fails when portfolio decisions are made based on local preferences rather than enterprise direction. The result is a landscape that is expensive to operate, hard to integrate, and slow to change. In phase C, you aim to create clear application boundaries, aligned to capabilities and value streams, so every system has a purpose, and duplication is a conscious exception rather than the default. Now that you know the failure patterns, you use capability to application mapping to bring discipline to the application landscape. You map which applications support which capabilities and where the overlaps exist. This gives leaders a portfolio view that can drive rational decisions. Consolidate here, modernize there, retire this, and invest in that. It also helps delivery teams understand which systems are strategic and which are legacy candidates. The key leadership benefit is that it forces a hard question. If an application does not clearly support a capability that matters, why does it exist? This is how architecture controls cost without becoming an opinion fight. With mapping in place, you need to define application boundaries so integration does not become a tangled web. Boundaries clarify what each application is responsible for and what it should not do. When boundaries are unclear, systems start absorbing responsibilities they were not designed for, leading to fragile integration and high change cost. Clear boundaries support a simpler integration landscape because data and responsibilities flow in predictable ways. In phase C, your job is to define boundaries aligned to capability ownership and authoritative data sources, so the application landscape becomes easier to govern and easier to evolve. Now that boundaries are clear, you can lead rationalization in a way that respects operational reality. Rationalization is not only about shutting systems down, it is about reducing duplication, reducing licensing costs, and simplifying operations while protecting business continuity. You classify applications based on strategic fit, risk, cost, and business criticality. You then decide whether to invest, tolerate, consolidate, or retire. The key to doing this practically is sequencing, because retiring a system too early can break value streams, while keeping duplicates too long increases cost and confusion. Phase C helps you make rationalization an accountable, governed decision process rather than a political battle. With application decisions guided, you need integration and interoperability direction because value streams cross multiple systems. Your goal is not to create a perfect integration diagram. It is to establish consistent integration principles that reduce risk and rework. You define expectations for how applications share data, how events and changes are communicated, and how interfaces remain stable. This supports delivery speed because teams can reuse integration patterns instead of inventing new ones each time. It also supports resilience because consistent integration reduces fragile point-to-point dependencies that cause outages and long recovery times. Now that the principles are clear, imagine you are guiding Phase C for a digital customer channel transformation. Your business architecture identified onboarding and service requests as critical value streams. In data architecture, you define customer and identity as critical data domains and clarify authoritative sources for customer identity and account information. You establish ownership for customer data and define control sharing to digital channels. In application architecture, you map which systems support onboarding and service requests, identify overlaps, and define boundaries so digital channels do not create their own customer truth. You create a direction that reduces duplication, improves data consistency, and makes integrations predictable. The outcome is a digital platform that improves customer experience while reducing operational rework and data inconsistency. Building on the customer example, consider an operational environment where asset and workforce management is central to value delivery. Your data domains include assets, work orders, workforce identity, and location. You define authoritative sources and ownership so that maintenance decisions, scheduling, and reporting use consistent data. Your application architecture maps how work management, inventory, and scheduling systems support operational capabilities, and you identify duplication that creates inconsistent reporting and delays. You then set direction for consolidation, clear boundaries, and reliable integration. The result is improved operational predictability, fewer manual reconciliations, and stronger audit and compliance readiness. Now that examples are clear, you connect Phase C back to governance because data and application decisions must be enforceable. You translate your Phase C direction into standards such as data ownership rules, authoritative source definitions, integration expectations, and application boundary principles. You define what evidence is required to show compliance, such as mapping of applications to capabilities and confirmation of authoritative data usage. You also define how exceptions work, because reality will require deviations. This governance connection is what makes Phase C sustainable. Without it, the architecture becomes advice. With it, architecture becomes an enterprise decision system that controls risk and cost over time. With governance integrated, you should avoid two extremes. Over-design happens when you model everything in detail and delay decisions. Under-decision happens when you produce general statements and leave teams guessing. Practical Phase C sits in the middle. You make the critical decisions about data ownership, authoritative sources, application boundaries, and rationalization direction, while leaving detailed implementation design to teams within guardrails. This approach respects delivery speed while protecting enterprise coherence. It also ensures architecture remains useful because it drives real decisions instead of becoming documentation theater. Let's now discuss the key takeaways from what you learned so far so you can apply it immediately. You learned that Phase C information systems architecture is where you create data and application direction that makes business architecture executable and sustainable. You learned that data architecture becomes practical when you define data domains, establish authoritative sources, and assign ownership and stewardship that can be governed. You learned how controlled data sharing enables value streams while protecting privacy, security, and compliance risk. You learned that application architecture becomes effective when you map applications to capabilities, define clear boundaries, and rationalize duplication through accountable portfolio decisions. You learned that consistent integration and interoperability direction reduces rework and fragility, while enabling end-to-end value streams. You learned through examples how Phase C prevents multiple truths, reduces operational friction, and strengthens delivery predictability. Finally, you learned that Phase C only works long-term when it is connected to governance through standards, evidence, and transparent exceptions. Now that you understand how to run Phase C information systems architecture in a practical way, you are ready to shape data and application decisions that reduce duplication, strengthen governance, and enable real outcomes. Subscribe to the channel, like this video, share it with your architecture and delivery peers, and comment with the most common Phase C problem you see in organizations today, such as duplicate systems, inconsistent data definitions, or unclear ownership, and what impact it is causing in your environment.